The day oxygen killed almost everything. Earth's first apocalypse. Introduction. The paradox of existence. When we look up at the sky today, we see a vast, comforting expanse of blue. We take a deep breath, filling our lungs with the oxygen that fuels our blood and powers our consciousness. In our collective imagination, oxygen is synonymous with life. It is the breath of vitality, the prerequisite for complexity, and the fuel of civilization. However, hidden deep within the geological strata of our planet lies a darker truth, a chapter of Earth's history where this life-giving gas was the ultimate villain. This is the story of the Great Oxidation Event, also known to scientists as the oxygen catastrophe. It's a tale of biological innovation, chemical warfare, and a planetary reset button that occurred approximately 2.4 billion years ago. To understand our origins, we must first understand the apocalypse that paved the way for them. This was the moment when Earth choked on its own breath. The alien world, Earth before the change. To truly grasp the magnitude of this event, we must transport ourselves back to the Archean Eon. If you were to stand on the surface of Earth 3 billion years ago, you would not recognize your home. The sky was not blue, but likely a hazy, muted orange or pink, choked with methane and carbon dioxide. There was no ozone layer to shield the surface from the sun's scorching ultraviolet radiation. The oceans were not the deep blue we know. They were likely green due to high iron content, or perhaps purple, teeming with strange single-celled organisms. Life in this epoch was simple but robust. The dominant life forms were anaerobic bacteria and archaea. These microscopic entities had evolved to thrive in an anaerobic environment. For them, oxygen was not a fuel, it was a destroyer. Their metabolisms relied on chemicals like methane and sulfur. They lived in a delicate balance with a reducing atmosphere, a world where the chemistry was fundamentally different from what we experience today. For hundreds of millions of years, this was the status quo. Earth was a quiet, anaerobic world. But in the shallow, sunlit waters of the primordial oceans, a biological revolution was brewing, a mutation that would spark the greatest environmental disaster in history. The culprit, the blue-green revolution. The agents of this destruction were not asteroids from space or massive volcanic eruptions from the deep. They were microscopic. They were cyanobacteria, often referred to as blue-green algae. Somewhere along the evolutionary timeline, these ancestors of modern plants figured out a way to harness the energy of the sun more efficiently than any organism before them. They developed oxygenic photosynthesis. By using sunlight to split water molecules, they could produce energy to build their cells. It was a brilliant survival strategy, offering them an unlimited power source. However, this process had a byproduct, free oxygen, O2. At first, the oxygen produced by these tiny innovators did not impact the atmosphere. The Earth is a vast chemical system, and it had mechanisms to absorb this new element. The early oceans were rich in dissolved iron. As the cyanobacteria puffed out microscopic bubbles of oxygen, the gas immediately reacted with the dissolved iron. This chemical reaction is familiar to anyone who has left a bike out in the rain. Rust. For millions of years, the Earth literally rusted. The iron in the oceans oxidized and precipitated out of the water, falling to the seafloor in massive layers. Today, we see the evidence of that era in banded iron formations, BIFs, distinctive sedimentary rocks consisting of alternating layers of iron oxides and iron poor chert. These formations are the primary source of the iron ore used in our industries today. Every steel beam and every skyscraper contains the rusted remnants of that ancient chemical war. The tipping point, when the sinks filled up. Nature, however, has its limits. The dissolved iron and other oxygen sinks, reservoirs that could absorb oxygen, were finite. The cyanobacteria, fueled by the inexhaustible power of the sun, continued to multiply and pump out oxygen relentlessly. Eventually, the oceans ran out of iron. The sponges were full. Around 2.4 billion years ago, the buffering capacity of the Earth collapsed.
With nowhere else to go, oxygen began to bubble out of the oceans and into the atmosphere. The gas began to accumulate, and the Great Oxidation Event officially began. This shift in atmospheric composition was catastrophic for the existing biosphere. To the anaerobic organisms that ruled the world, oxygen was highly toxic. Oxygen is a reactive molecule. It strips electrons from other molecules in a process known as oxidation. Inside the cells of anaerobic bacteria, free oxygen wreaked havoc, destroying enzymes and DNA. It was a massacre on a microscopic scale. As oxygen levels rose, the anaerobic dominance crumbled. The vast majority of life on Earth was wiped out in what remains the most significant mass extinction in planetary history. Survivors were forced to retreat into the deep, dark corners of the Earth, into mud, deep ocean vents, and oxygen-deprived pockets, where they still linger today. The surface world was conquered by the oxygen producers. The deep freeze, the Huronian glaciation. The catastrophe did not stop at biological extinction, it triggered a climatic collapse. Before the rise of oxygen, the Earth stayed warm thanks to a thick blanket of methane, a greenhouse gas roughly 30 times more potent than carbon dioxide. This methane layer kept the planet habitable despite the sun being significantly dimmer, about 70 to 80% of its current brightness at that time. As oxygen flooded into the atmosphere, it reacted with the methane, converting it into carbon dioxide and water. While carbon dioxide is also a greenhouse gas, it is far less effective at trapping heat than methane. The result was a sudden and drastic drop in global temperatures. The thin atmospheric blanket was ripped away. The Earth plunged into the Huronian glaciation, a deep freeze that lasted for roughly 300 million years. Glaciers extended from the poles all the way to the equator. The entire planet may have turned into a snowball Earth, a white, frozen wasteland hurtling through space. The Cyanobacteria, the very architects of this disaster, nearly caused their own extinction as the liquid oceans they relied on froze over. Life hung by a thread. The resurrection, a new world order. Yet, life is remarkably resilient. The Great Oxidation Event was a bottleneck, a filter through which only the most adaptable could pass. It destroyed the old world, but it laid the foundation for the new one. The presence of abundant oxygen forced a new evolutionary path. Some organisms developed mechanisms not just to tolerate oxygen, but to utilize it. This was a game changer. Aerobic respiration, using oxygen to burn food for energy, is roughly 18 times more efficient than anaerobic respiration. This massive boost in available energy allowed life to grow larger, more active, and more complex. It is believed that during this turbulent time, or shortly after, a momentous biological merger occurred. A large predatory microbe engulfed a smaller bacteria capable of using oxygen, but failed to digest it. Instead, the two formed a symbiotic relationship. That internal bacteria eventually evolved into the mitochondrion, the powerhouse of the cell. This endosymbiosis gave rise to eukaryotes, the complex cells that make up all plants, animals, and fungi. Furthermore, as oxygen accumulated in the upper atmosphere, it interacted with sunlight to form ozone, O3. The ozone layer began to take shape, creating a shield against lethal UV radiation. For the first time, the dry land, previously sterilized by radiation, became a potential habitat for life. Conclusion: the legacy of the catastrophe. The Great Oxidation Event serves as a humbling reminder of the power of life to shape the planetary environment. A single type of single-celled organism completely rewrote the chemistry of the atmosphere, geology, and climate of Earth. It destroyed an entire biosphere and froze the world, yet without this disaster, we would not be here. We are the children of that apocalypse. The oxygen we breathe, the ozone that protects us, and the complex cells that compose our bodies are all legacies of the moment Earth became poisonous. It teaches us that in the grand narrative of geology and evolution, destruction and creation are often two sides of the same coin. The poison of the past became the elixir of the future. As we look at our modern impact on the climate and atmosphere, the story of the Great Oxidation Event resonates with a haunting familiarity. It stands as a testament to the fact that when the atmospheric balance tips, the consequences are swift, global, and irreversible. The cyanobacteria changed their world blindly. We, however, have the burden of knowing exactly what we are doing.
Thank you so much for watching all the way to the end. If you enjoyed this video, learned something new, or simply want to see more content like this, please give it a like and subscribe to the channel. Your support truly helps the channel grow and reach more people. And if you have thoughts or ideas you'd like to share, feel free to leave a comment. I'd love to hear from you. See you in the next video.